In this lesson, we're going to solve systems of linear inequalities. So what's the difference between this and the last lesson we just did? Well, now we're going to have a system of inequalities instead of just one. So we're going to have two or more linear equations. And that's pretty much it. So we'll graph both of them and see where they both shade and be our solution. So our first example, tell what are the ordered pairs of solutions to the given system of inequalities. So much like we did last time, we're going to substitute our point into both equations because it's a system. Now we have two equations. And if it works for both of them, it's a solution. If it doesn't work for one of them, then it's not a solution, right? So it has to work for both for it to be true. So here's our x, here's our y. Plug into the column real quick. 1 is less than 1/2 times 1 plus 3. So that's 1 is less than 3.5. That's true. All good. Let's try the second one. So 1 is greater than -1 plus 3. 1 is greater than 2. That's not true. 1 is not bigger than 2. So this is no, not a solution. Right? So again, as long as it fails one, it fails both. Right? It has to fit, has to be true for both of them. So we try this one here, same idea. Here's my x, here's my y. Plug into the top. 2 is greater than -2 minus 2. So I get 2 is greater than -4. That is true. Plug into the bottom one. So 2 is less than 2 times 2 plus 3. So 2 is less than 4 plus 3. So 2 is less than 7. That is true. So it's true for both. So this is a solution. Right? So that's how you could tell with the point, right? If you want to do a test point, that's how you could tell. Plug into both of them, it has to be true for both of them to work. But other than that, we're just going to graph both our systems. We're going to graph them both, and then where they both shade is our solution. So a couple of reminders from how we graph linear inequalities. First, we're going to graph the line like normal, like if it's a slope-intercept form, graph the boundary line. Then we got to decide is the boundary line solid or dashed. Remember the way we did that for the line. If it is less than equal to or greater than equal to, that's a solid line. So when we did one equation, it was a closed circle. For us, that's a solid line. And if it's just greater than or less than, so that's going to be dashed. Because you cannot be the line, so it's a dashed line. You can't be the line. For shading, you could do a test point. Or if you're less than, and we have it in proper notation, then we're going to shade below. Right, you're less than the line, you're below it. And if you're greater than, then you're going to be above the line because you're greater than the line, so be above. Again, those only work in proper notation when y is on the left-hand side. Okay, let's do a couple examples. So we want to find the solution to this system here of inequalities. So we're going to graph 1. So my y-intercept, my b, you could say, is 3. My slope is -2/3. So remember, that's rise or run. We're going to go down and over 3, right? Positive go up, negative go down, but we always want to run to the right. So starting at this point, we're going to go down 2 and then right 3. So right there, look at it. It is a dashed line, no equal to sign, so dashed, and then we're going to shade below. So dashed, let's do dash, that's solid, dashed, and then we want to shade below. So let me do this for a little shading. Kind of like that, right? Lightly with your pencil. Okay, next, I'm going to graph this line. So same idea, right? It's another dashed line, no equal to sign. My b here is -1. And my m is 3/2. So positive, we're going to go up 3, and we always go to the right. So from this point here, we're going to go up 3, and then right 2. So like right there, another dashed line. And then this guy, we're going to shade greater than, so we're going to shade above, right? So this is less than, so that's below. This is greater than, so that's going to be above. So let's go here. So it's going to be kind of like this. Right, and then wherever they both shade, that region there, that's our solution. So in this case, our solution will be all of this. So any point in this region here is our solution. So this whole solution works. Okay, so that's the general idea. Let's go on to this one. Right, same concept. Right, so we're gonna graph that one. My y-intercept here is -2. My slope is -1. I'm gonna make that a fraction, -1 over 1. So we're gonna go down 1 and right 1. So down 1, right 1, right there. This is a solid line, right? Because it has an equal to sign, so solid. and it is greater than, so we're going to shade above. So I'm just going to kind of like do this. Kind of like that, right? Okay, the bottom one. So my y-intercept is 1, so we'll start at 1. My slope is 2, so I'll make that 2 over 1. So I'm going to go up 2, right 1. So like right there. It's another solid line, right? We see the equal to sign. And it's another greater than, so we're going to shade above this one also. So I'm just kind of do this. Right, and my solution will be where they both kind of cross shade. So my solution is going to be all of this. So you do have to mark down where they both, where your solution is. You can't just like let it be for chance. You got to actually like take a stand. So that's my solution. Let's do a couple more. Okay, so this one here, if you notice, there's only one variable. So these are my favorite. Some people overthink them, right? So with that one, you just go to where x equals -3 right here, and you follow the tally mark. So keep in mind, so the check, it is dashed, right? No equal to sign, and it is less than, right? It's like a little less sign. That means we're gonna go down, below. Well, how about that means for a straight line? Oops, dashed. There we go. So less than in this case, what numbers are less than -3? That'll be the left-hand side. So remember, it's up and down. Less than is to the left. So like right there. Okay, the bottom one here, if you notice, it's not in y equals mx plus b form. So first we have to move it. So let's subtract. I'm gonna put this in y equals mx plus b. Sorry, so let's subtract the x from both sides. So you get -2y is less than -x plus 2. And then we're going to divide by -2. Keep in mind we divided by a negative, so we have to switch the inequality. Anytime you multiply or divide by negative, you got to switch the inequality. So this is going to become a negative, so I'm just going to leave it as x over 2 and then -1, right? So 2 divided by -2 is -1. So in this case, my y-intercept is -1. My slope is 1 over 2, right? The coefficient of x is 1. So we're going to go up 1, right 2. So like that. It is solid in this case. It's a bad line. There we go. And again, since we divide by negative, we have to switch inequality, so we're going to actually say it above now. So kind of like this. Then you got to justify your answers. My answer is right here. That's where they both shade. So something to that effect. Let's look at this one. So y is greater. Look at both ones. Slope intercept are nice. So right here, my y-intercept is 2. My slope is -1 over 1. So I'm going to go down 1, right 1. So like that. It is solid, right? And it's greater than, so I'm going to say it above. So let's graph that. So solid line. And we're going to shade above. Okay, the next one down there. So this one, my y-intercept is -2. Slope is the same, -1 over 1. So that means that these are going to be parallel. Same slope, so down 1, right 1. It is dashed. And that's a less than sign. You can spell it looks like a L, so we're going to say below. So this one should be dash. Let's try to make that more of a straight line. And we're going to shade below it. Now, if you notice here, in this case, there's no overlap. So this is no solution, right? Because there's no overlap. So in that case, you have no solution. Okay, next thing. What if I want you to go backwards? What if I want you to write an inequality for this? So it's kind of like when we did it for the one equation, but now we're just going to do it two. Just if I'm going to be honest about it. So let's do this equation first. So equation 1. Right, so remember, our general standard is going to be y equals equal to mx plus b. But we want to have to change the equal sign. It has to be an inequality. So let's look at this red one here. Equation 1. Now that one looks like it's shaded below. Right, so that means it's going to be a less than sign. And it's not equal to, so it'll be like this. So this guy's going to be this guy. So all we have to do is find the y-intercept and we have to find the slope. So my y-intercept for this one looks like it's right here. I would say that is 3. And then we have to find the slope. So find another edge where it crosses nicely. Oh, this grid makes it ugly, but I do believe right there works. So that's 1 and 2. So my slope here would be 2 over 1. So there's my equation. Y is less than 2x plus 3. Right? So I start at 3, my y-intercept. My slope is 2, so over 1 up 2. And then it is shaded below, and then no inequality. Second one, same idea. Number 2 here. Right? So again, we're looking at this guy. But in this case, it is a solid line. And it looks like it's shaded above. You can tell by the little blue right here, right? So it's shaded above. So that's going to be greater than because it's shaded above. Right? So solid line and shaded above. So it'd be like that. So we just find the two things again. Find the y-intercept, which looks like it's 4. And then the slope. Again, these slopes are a little tough. It's hard to see in this picture. But it looks like this and this. Let me use these two. That looks nice. So it's going to go down 1 and right 1, right? We always go to left to right. So in this case, down 1, right 1. So my slope is going to be y over x. I went down on my y and I went 1 on my x. So negative 1. So my equation for 2 is y is greater than or equal to negative 1x plus 4. Or just negative x plus 4. Okay, so that's the idea there. This would be the same thing. I'm going to skip that one just for sake of time. And let's finish off looking at an application problem. So Malia has $500 to purchase water bottles and a pair of socks for a fundraiser for her cross-country train. Water bottles cost $2 each. A pair of socks cost $3 each. She needs to buy at least 200 items without buying too many of just one item. What graph shows the possible numbers of water bottles and pairs of socks that Malia should buy? Okay, so we're going to set up an equation here. So let x be the number of water bottles, and let y be the number of socks. So we have a total. So we're going to do like this. We're going to have a total, and we have a cost equation. So total things you could buy, right, is 200 items. So our total is going to be x, which is water bottles, plus y has to be less than or equal to 200. And actually, I didn't at least 200. That's the way around. That means the lowest is 200. So it should be greater than or equal to 200. That should be our equation, right? We have to buy at least 200 items for the raffle or whatever it is. Okay, so that's our total. We have to buy this guy plus this guy has to be at least 200. Now we have to do the cost. So water bottles, which is x, they cost $2 each. So 2x. And then socks, which are y, cost $3 each. So plus 3y. And then how much we have to purchase, like how much money we have? We have $500. So this one is going to be less than or equal to 500. Because you can't spend more than the money we have. So you can't spend more than 500. So here are two equations. And what we do next is we will graph them. So right, to put them in slope-intercept form. So this guy is not too bad. Minus x from both sides. Y is greater than negative x plus 200. This guy's a little bit more work. You gotta subtract 2x. So you get 3y is less than negative 2x plus 500. Then we have to divide everything by 3. So y is less than negative 2x over 3 plus 500 over 3, which is some decimal. Once we do that, we have to graph it. Again, these are big numbers, so we need either a big graph or a calculator. So graph them like this. And then you shade each, right? So if you look at this, the yellow one, the orange one, I should say, I know my colors, is greater than. So here's a line, and we shade above it. And then this right here, this one, they did it in blue. That's what this line is. So that's this line, they should shade below it. So our answers could only be where they both shade. So that's right there. Anything in that range is a solution. Right? Because it's below this blue line, but above this orange line. That's where the solution lies. So any combination of whole numbers in here is a solution. So any combination, gotta make sure the whole number is gonna buy half a sock of whole number values in shaded region is the solution. Right, so for one example, if I pick a point, let's say like that right there, that looks like it might be 200 and let's say 20, like that point right there. That means we have 200 water bottles and 20 socks, right? That works. But that's not the only solution. I could do the one right here. It looks like if I buy 0 water bottles, socks, and I buy all water bottles, or a point over there where I buy 40 socks and like less water bottles, right? Anything in this little answer here is a solution. And that's how it works with inequalities. And that's the lesson.